Hello, my name is Ziran. I'm in Group E. Today, I'm going to talk about my software design of the Rubik's Cube group project. As you can see, this is the starting page. First, let's have a look at some instructions of the program. We'll go through these instructions in the following video, but if you want to have a look at them, you can pause the video here. By clicking the Start button, we can go to the main page of the program. As you can see, at the center of the screen, there is a rendered 3D Rubik's Cube rotating around its center point. And on the two sides of the screen, there are some menu items indicate the functionality of the program. The first functionality implemented in the program is scramble the Rubik's Cube. There are three ways to scramble the Rubik's Cube. Firstly, a user can use keyboard strokes to manually scramble the Rubik's Cube. As shown in the screen now, a right face rotation is applied. This is achieved by pressing the R key. The rotations just shown in the screen are the standard clockwise rotations. If the user want to apply anti-clockwise rotations, this can be achieved by pressing the left shift key and the first letter of the name of the face. For example, if a anti-clockwise front face rotation needs to be applied, this can be achieved by pressing the left shift key and the F key. As you can see, the applied rotations are displayed on the top of the screen. The other faces of the Rubik's Cube can be observed by holding the left mouse button and drag the Rubik's Cube as shown here. While the Rubik's Cube is rotated by the mouse, the face rotations can still be applied. This can make the manual scramble process much easier. We will talk about the other two scrambling process later. Now let's have a look at the most important functionality, which is the solve function. A scrambled Rubik's Cube can be easily solved by clicking the solve menu item. As you can see here, when I place my cursor on top of the solve menu item, the color of it is changed to red, and a short description of the functionality of the menu item is displayed on the top of the screen. After we click the solve button, the solving process started. As you can see, the current move is highlighted in red, and when the current move is completed, it is popped off from the screen, and also the solve time is displayed at the bottom of the screen. When the solving process is completed, the total solving time is again displayed at the bottom of the screen, and the solving moves are also displayed here. Now let's go back to the scramble of the Rubik's Cube. The second scrambling method can be started by clicking the menu item showing here. And in this method, the program randomly generates 20 moves of rotations to scramble the Rubik's Cube. After clicking the scramble menu item, the scrambling process is started. Again, the total moves and the current move are displayed at the top of the screen, and the scrambling time is displayed at the bottom of the screen. As you can see here, we can also observe the other faces of the cube during the rotation. And we can also adjust the speed of the rotation by pressing the up arrow key and the down arrow key. The up arrow key is for speed up, and the down arrow key is for slow down. When the scrambling process is finished, again here you can see the scrambling time is displayed at the bottom of the screen, and the previous scrambling moves are also displayed here. This scrambling process can be repeated for multiple times, and here we increased the speed of the rotation. Again, we can use the solve function to solve the Rubik's Cube. And finally, the third method to scramble the Rubik's Cube is to use a predefined 18 moves of rotations in an ASCII text file, as shown here. After we click the ASCII menu item, this scrambling process is started. We increase the rotation speed here again to go through this process quicker. As you can see, the 18 moves defined in the ASCII text file are exactly the same as the moves displayed in the program. Here we will solve the scrambled Rubik's Cube one more time. And the last functionality implemented in the program is enabling the output of the audio frequency analog signal by clicking the motor menu item. When this functionality is activated during the scrambling moves and the solving moves, the program will send out corresponding audio signals to the filter circuits to rotate the motor shafts. Some examples of the output audio signals are shown here. Since we are not connected to the server box now, we will turn this functionality off. And now when we apply a front-facing rotation, there is no audio output anymore. Let's again solve the cube, and we will move to the color detection module. Two color detection mechanisms were developed in the program, which are box cam mechanism and the webcam mechanism. The first two menu items are the functionalities of the box cam mechanism. The box filter is used for calibrating the color filter values for the box cam. And because we are not connected to the server machine, this functionality is not demonstrated here. The box scan uses the two external cameras mounted inside the actuator chassis to obtain the initial state of a scrambled Rubik's Cube. Again, because we are not connected to the server box, I will use two images captured previously in the lab to demonstrate this color detection method. As you can see here, the color detection is performed automatically. The image on the left-hand side of the screen is the bottom camera view, and the image on the right-hand side is the top camera view. Each camera can see three faces of the scrambled Rubik's Cube. The detected color for each square is displayed in the images, and the total detection time is also displayed on the screen, which is around 1 second. After obtaining the color detection results, the image windows can be closed by pressing Escape key, and the color of each square is automatically transferred to the rendered 3D Rubik's Cube. Additionally, as shown at the bottom of the screen, the program also calculates the number of each detected color, which can be used to check whether the color detection results are correct. If the detection is wrong, the color of the rendered text here will be red. In this case, the number of each detected color is 9, which means the results of the color detection are correct. Indeed, and we successfully obtained the initial state of a scrambled Rubik's Cube. And now let's quickly solve this scrambled Rubik's Cube. The second color detection method is the webcam color detection mechanism. Similarly, the web filter is used to calibrate the color filter values for the webcam. Since the current landing condition is the same, there's no need to recalibrate the filter values now. Unlike the previous method, the web scan only uses the laptop's built-in webcam to detect the initial state of a scrambled Rubik's Cube. Before we demonstrate this color detection method, let's scramble our Rubik's Cube first. As you can see, I'm just randomly rotate the Rubik's Cube here. Now you can see each face of the Rubik's Cube is completely scrambled. And now let's detect the initial state of this Rubik's Cube, which has just been scrambled by me. As you can see, this color detection mechanism is performed in real time, and you can see the change of the detection results on the left-hand side of the screen. The face which needs to be scanned is also displayed on the screen, and the scanning order is always the same, which is green, orange, blue, red, white, and yellow. And for each phase, when the color detection results are confirmed, the space bar needs to be pressed to save the detection results. So the color of the next phase can be detected. And you can see here the number of each detected color is 9, which means there's a large chance the color detection results are correct. Now, in order to see if the color detection results are correct, we will further verify the color of each square. And as you can see now, the color of each square on the rendered Rubik's Cube matches the scrambled cube on my hand. And now we have verified the detected color of each square is correct, which means the initial state of the scrambled Rubik's Cube is obtained. Just to prove the solving algorithm is working correctly, I will follow the moves generated by the solving algorithm to solve this scrambled Rubik's Cube here manually. Just before we start, because the program is designed for using with high-speed motors, it is hard for me to catch up with the speed of the solving algorithm, even if I slow down the rotation speed. So I added a read input line command in my code between each rotation. So basically, after a rotation is applied, the solving algorithm will stop and wait for me to type a new line in the terminal. And this will give me enough time to catch up with the speed of the solving algorithm. And this is only needed for this demonstration purpose. This line of code is removed when the program is working with the solver box. And now we have successfully solved a scrambled Rubik's Cube in 21 moves. Finally, there is one more functionality implemented in the color detection module, which is the patch function. Sometimes color detection cannot achieve 100% accuracy. Obviously, we can always rerun the color detection module until we obtain the correct color detection results. But if the color detection module keeps failing, we have to make sure there is a way to solve the cube so the rest of the system can still function. As a result, the patch function was developed to overwrite any color on the Rubik's Cube. Firstly, let's make a clockwise down phase rotation. and we will use the patch function to change the color of the top left corner piece on the front face to color red. As you can see in the terminal, firstly we typed in the face F and the location of the square, which is numbered as 0, and we typed in the color we wish to change it to, which is red. And you can see the top left corner piece of the front face is changed to red. And now there are 10 red squares on the Rubik's Cube. So if we imagine this is the color detection results from a scrambled Rubik's Cube, and we want to solve this cube. And when we click the solve menu item, the solve function will tell us that this is an incorrect color detection because there are 10 red squares and only 8 green squares. The cube is insolvable. So in this case, we can use the patch function to change the color of the top left corner piece of the front face back to green. And now when we apply the solve function, the cube is solvable. And this concludes all the functionalities implemented in the design. I hope you enjoyed this video, and thanks for watching.